In this video, we're going to do something a little different. We're actually going to be covering 3 sections at once. What sections we're covering are sections 6.2, 6.3, 6.4. What those sections all cover is factoring trinomials. Okay, trinomials meaning a polynomial with 3 terms. Now, the reason I do this in one big discussion is because years ago when I did this separately, it caused a little bit of confusion for students. 6.2 is talking about trinomials that are very, very simple, basic trinomials. What makes them simple is that the leading coefficient, the first number, is always going to be a 1. There are certain things that you don't have to worry about when that happens. And what I saw was students were still doing the simple method when the problems got a little bit more complicated. Section 3 is actually the section that I'm going to be discussing in this video. Section 4, what they have you do is they have you take a 3-term trinomial, break it strategically into 4 terms, and then use grouping. I did that for a very, very long time with my students, but what I found later was that when they got into more complicated chapters, that method's a little longer, so they were too slow with more complicated applications, and it really bogged them down. So that's why I kind of avoid that as well. Now, the method that I'm going to be showing you that is discussed in section 3 is called guess and check. Okay, that's the method we use for factoring trinomials. If you have another method that you like, a lot of people do like factor tables, factor trees, or they use what I used to call a MA table, a multiply and addition table for the grouping. If you like using those methods, by all means, continue to do so. However, when we get into chapter 7, there will be problems where we have to do maybe 4 to 6 of these in one problem. If you're building 4 to 6 factor tables or doing a MA table 4 to 6 times in each problem, it's really going to slow you down, and you won't be able to really practice and appreciate the new material at that time. So I really suggest give this a shot, but maybe use those other methods when this gets a little bit too complicated in certain situations. Okay, now before we actually get into the factoring using guess and check, I want to review FOIL, which is just a fancy way of distributing 2 binomials. FOIL is really where the guess and check is coming from. That's what we're undoing when we're doing the factoring. So let's start out. I just want you to multiply a 2x plus 3 and a 4x minus 5. Okay? If we were to FOIL this, we go through this pretty quickly. We just go 8x squared minus 10x plus 12x minus 15. Okay, and when we deal with that FOIL idea, this was from the firsts, the outers, the inners, and the lasts. Okay, now that typically is not how we leave it, though. What we typically do is combine these middle terms, and we would get something like that instead. And that's where the trinomial is coming from. Now remember, where's that trinomial getting its terms? This first term comes from the firsts. The last term comes from the lasts. But that middle term is actually a combination of the O and the I of FOIL. The whole idea of guess and check comes from guessing values that will give you the first and the last, and then checking to see if the O and the I in the middle actually come out as well. Okay. Now, when you say guess, a lot of people think, well, I'm just randomly picking numbers out of thin air. You're not exactly picking random numbers. You're picking numbers that specifically will multiply to this and multiply to that. Okay. However, you're guessing from a few options, and we need to find the right option and the right combination that will give us this as well. Okay, so that's pretty much the idea that we're going after. Let's now jump through a few examples of this. This will be slow at first, but the more you do, the more you practice, this is actually a very, very quick way of factoring after you get good at it. So give yourself a chance, be patient, and it'll get better. Okay, first one, all I'm going to say is factor. That's it. Remember, that's that verb of writing it as a product. And let's start out with this. Here's your trinomial, okay? Now, I'm going to start always by asking, is there a GCF in this case? And as you can see with all three terms, there's no GCF. So we're going to go into guess and check with three terms. Remember, if it was 4, we would be doing grouping. But with 3 terms, I try to build 2 binomials. Now, what I always like to do before I jump into this is I write the factor pairs for the first and the last. This is really the only work that you should be showing, okay? 2, the only 2 integers that multiply to a 2 are a 1 and a 2. Or you could say 2 and 1, it's the same thing. 15, you can have 1 and 15. You can have 3 and 5. Those are the numbers that you are going to be guessing. You have to figure out which combination and in which order is going to work. Now, the good thing is there's really nothing to guess here. You have to use 1 and 2 to start. But remember, it's a 2x squared. So if I'm going to multiply that, I want to break up the variable evenly. So I'm going to have a 2x and a 1x. Or I could put 1x then 2x, whatever you prefer. Now, I have a 15 here. So I have to go with a 3 and a 5 or a 1 and a 15. Guess. Just make a guess. I'm going to go with the 1 and the 15. Okay, just for the sake of argument. So I want to have a 1 times a 15. That will give me that. So I guaranteed that 2x squared and 15 will be the first and the last. Now, what I need to check, the only thing I need to check is if the outers and the inners give me that 13 I'm looking for in the middle. Okay, so if I try that, again, I'm only doing the O and the I of FOIL here. I've got 30x plus 1x. That's 31, not 13. That combination, that guess, didn't work. So now I'm going to switch this. I'm going to put a 15 here and a 1 here. Maybe that'll work. I get 2x, 15x. 2 plus 15 is 17. That didn't work. What some people try to do is they'll say, well, I'm going to do that because watch, I get negative 2x plus 15x. That gives me a 13. But what did you just lose? You just lost the positive 15 that we're supposed to have at the end. Don't mess with the signs unless you're getting the right number to begin with. Okay? So what I should have done is left that and say, this isn't working because I was getting 2 plus 15, that's 17. No good. It's not the right number. Okay, so that means 1 and 15 didn't work. That's out. So what's my next option? I go to the 3 and the 5. I'm just going to put a 3 here, 5 here. Let's see if it works. I get 10x, 3x. There's my 13. And now I have it factored. That's what guess and check is. Now, guys, sometimes you will get lucky and the first one you try, it works. And that's great. Sometimes you are going to have to go through a few. That's normal. That's natural. Just carry out the process. That's all you have to worry about. So this is your factor form. Okay? Don't be afraid to try this problem out on your own. You know, you look at this, you understand it. The day after we go through this or you watch this video, then try it again on your own. Write that problem out. See if you can remember how to go through it. Okay, don't try and memorize the answer. Memorize the process. Let's look at another one. Okay, here's your trinomial. Now, first thing, Is there a GCF? In this case, the answer is no. Remember that. That's going to be very important in a few minutes here. The next thing I would do once I look at that and say, I need to do guess and check, I would list all the factor pairs for the first and last terms, okay? Don't randomly pick numbers. 1 times 36, 2 times 18, 3 times 12. Do you see how I'm going through this strategically and in order? I don't miss anything that way. 4 times 9. 5 doesn't go into 36, so don't do that. 6 times 6. Okay, once you have that repetition going on here, or let's say I use a 9 again, then I'm done. Okay, those are my factor pairs for 36. How about 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't go in, and then I repeat that 6. I'm done. Those are my factor pairs that I have to guess through. Now, that's a lot, okay? And if we just randomly pick stuff, we could be sitting here for a while. Okay, you'll get the answer, but it might just take a while. So there's a trick you can use when you're going through these, okay? First of all, I usually start from this end of the list and work my way up. Typically, the answers are more toward here than here, okay? Again, that's just typically what gives me the results a little quicker, okay? Now watch, I'm gonna pick 6 and 6. The other thing I want you to not do is pick one, pick one, pick one, pick one, pick. Don't go back and forth because you're not gonna know what you tried and what you didn't try. I'm gonna pick 6 and 6, and I'm gonna try all of these. If none of them work, then I'm gonna go to 4 and 9. Then I try them all and so on. So I'm gonna go with 6R, 6R, okay? Again, R squared is R and R. Next thing I usually fill in, this is a negative 24. To multiply to a negative, I need to have opposite signs. So I'm just arbitrarily gonna put a plus and a minus in there, okay? Now let's try the 4 and the 6. I'm gonna put a 4 here and a 6 here. Check it. Again, O and I of FOIL, outers and inners. I've got negative 36R, positive 24R. Negative 36 plus 24 is negative 12, not negative 5. That didn't work, okay? Don't switch these because I already got the 6 and 6. It's gonna be the same thing. So then I would get rid of this. I will go 3 and 8. Do you see how this could be a long process? Let's cut to the chase here, okay? Remember the very first thing, no GCF. So then why on earth are you putting numbers here that would have a GCF? Why are you putting them here that would have a GCF? If there's no GCF here, there better not be any GCF here. Now, why is that good? Because don't even bother multiplying these. It's not going to work. 3 and 8, not going to work. 2 and 12. I can't put a 2 with a 6. I can't put a 12 with a 6. 2 and 12 are out. 1 and 24. I can't put a 24 with a 6. 1 and 24 are out. That means when I have these 6s, none of these will work. And I know that because they're going to give me a GCF that I shouldn't have. So 6 and 6 is completely gone. That wasn't a good option, okay? Now, the other thing is, guys, why were these no good? They were both 6s, but more importantly, they were both even. Everything here has an even number in it. I can't have an even with an even. So like this, don't even try. Because I would always be able to take a 2 out from something over here. Don't try it. Let's go with something, let's say 4 and 9. Let's try that. Doing this GCF trick doesn't jump you to the answer immediately, but it really speeds you up by letting you eliminate a lot of options that you just know are not going to work. So I'm going to go with a 9 and a 4. Okay? Now, let's go over here again, 4 and 6. Can I put a 4 here? Yeah, 4 and 9 don't have a GCF, but could I put a 6 here? No, because there's a GCF there. Don't even multiply that. It's not going to work. Let me switch them. 6 and 4. That's no good either because there's GCFs everywhere. So that's no good. Let's try 3 and 8. Can I put a 3 here? No, because 9 and 3 would have a GCF. Let's try 8 and 3. No GCF. That doesn't mean it's absolutely automatically correct, but it's worth checking. So now I'm going to check this. I got negative 27 plus 32. Again, outers and inners. Negative 27 plus 32. That right there gives you a positive 5. Notice I got the 5, but I got the wrong sign. Now, if I get the right number and the wrong sign, easy fix. Change, change. Change them both. You still get the negative 24, but now you also get 27 minus 32, negative 5. So that previous example where I said don't mess with the sign, don't mess with it unless you're getting the right number. I got the right number but the wrong sign. Switch them. You're good to go. And there we go. Okay, that GCF trick is very, very important. Take the GCF out in the beginning if you can, because then you can cut out a lot of possibilities that you don't have to multiply through because you'll know that they're wrong. Okay, let's look at another one. Okay, first, always, is there a GCF? In this case, there's nothing that divides all three of those evenly, but there are 3 terms, so that's going to lead us to guess and check. So I'm going to go with 2 binomials. The 8, right off the bat, has a 1 times 8, 2 times 4, 3 doesn't go into it, 4 we already have. 3 is a 1 times 3. Okay, now, a lot of people look at this and say there's so many variables, what do I do with all those letters? The variables will work themselves out, okay? What I mean by that is I got to pick one of these, and then this has to be 1 and 3. Let's go with 2 and 4, okay? Remember, it was x squared, so I got 2x, 4x. That's the same as we had in the other 2 examples. Notice this 3 at the end has a y squared, so you throw a y on each of those numbers as well. It's a plus, so I'm going to go plus 3y plus 1y. If you want to put the 1 in there so you see it, by all means do so. Now, where does this xy come from? Well, watch what happens. I've got 2xy. That happened on its own. Okay? Then I got 12xy. What's 2xy plus 12xy? 14xy. Right number, wrong sign. How do I fix it? Change, change. That's it. Okay. Now, I could have foreseen those 2 negatives at the beginning. If you have a negative here, this as the last sign right here, then these signs have to be opposite. Okay. Which is plus, which is minus, you got to play around with, but you'll know that they have different signs. If this is a plus, this last sign, that means that these signs should be the same, and they should both be that. Okay. If you can see that trick right up front, that can kind of jump you to the conclusion. But as you saw, if you don't see that and you just put the plus and plus, you can always fix it later. So that's nothing that you have to know and foresee to get the right answer. Okay, how about that? Okay, first of all, no GCF. Okay, so we're going to go into guess and check. What's nice here is I got 2 prime numbers. What multiplies to a 2? 1 times 2. That's it. What multiplies to a 5? 1 times 5. That's it. So I've got 2x and 1x. I'm going to have a plus and a minus. And I got the 5. I'm going to go 5 and 1. Okay, now I got to make sure I lined them up correctly though. So I've got negative 2x plus 5x. Negative 2 plus 5 is 3, not 30. Okay, if that didn't work, let's try another combination. Let's try 1 and 5. We've got negative 10x plus 1x. That's negative 9x. No good. What else can we do? There's nothing. We tried every possible combination, and guess what? None of them worked. If that's the case, we say prime. We can't factor that. End of story. Now, one word of advice and warning. Don't just automatically look at a problem and say, prime. That looks kind of hard. Prime. I'm tired. Prime. That is the last thing that you want to be writing down for a problem. Okay. If you try every possible combination and none of them work, then it's prime. But make sure you try all of them before you jump to that conclusion. Let's look at one more like this. Okay. Now, with this one, first thing always, is there a GCF? And in this case, we have a 3. Everything is divisible by 3. Take that out first. So I'm going to take a 3 out, and I got 2m squared plus 17m plus 10. Okay. Now, before you move on, stop and redistribute that. Make sure you did that correctly. You don't want to be spending 5 minutes trying to guess and check wrong information. Okay, so before you move on, check this, then go to the next step. We still have a trinomial. I got to try to guess and check. Don't forget that 3. Okay, what's nice is 2. 2 is 1 and 2. That's it. I'm going to go with 2m and 1m. I have plus and plus. Now, a 10 has a couple options. I can go 1 and 10. I could go 2 and 5. Pick one. Okay. The worst thing you can do is sit there and just think about it. Think about it. Think about it. At some point, you just got to execute it and see if it works or not. So I'm going to go with 2 and 5. Now, remember, I already took the GCF out. So don't put a 2 with a 2, because that would be a GCF that shouldn't exist. So I'm going to go with a 5 here, 2 here. I got 4 plus 5 is 9, not 17. So that didn't work. Normally I would switch these, but again, I can't put the 2 there. So that means that's out. It just doesn't work. So it must be 1 and 10. Now again, can I put a 10 here? No, because there will be a GCF. So the 10 has to go here, 1 here. That has to work, right? But we got 20 plus 1. 20m plus 1m is 21. No good. That doesn't work either. Okay, so if none of these combinations work, what do we say? Not prime. This is the factored form. Remember what the original problem was. Factor this. I did when I took the GCF out. I just couldn't go any further. This is garbage. Prime is when nothing works. Nothing works. Here, GCF did the job. Okay, so don't forget that that is a viable option when we're factoring. Anything should start with a possible GCF. Okay, again, guess and check. As you can see, there's not a lot of work to show. It's all happening up here, but you got to give it some time. You got to give it some practice. Okay, if the My Math Lab problems aren't enough for you, you want to drill a little bit more, look at the e-text. There's a lot of problems. There's more problems in there than you'll have time to do. Just keep drilling these, okay? This is a skill that is not going to go away. A lot of times when you get into like the college algebra classes or pre-calc or calculus, the problem that students have is not the calculus or the pre-calculus. It's this type of stuff. Okay, the same way that a lot of algebra students don't have a problem with the algebra necessarily, but with the arithmetic. So make sure you're always practicing and keeping your skills sharp with these types of procedures. One last thing that I want to talk about that is covered also in section 3 is something called a perfect square trinomial. This is a special pattern that if you have it down and you can recognize it, you can save yourself a lot of guess and check and a lot of time. So let's look at what that looks like. Okay, so let's look at something like that. Okay, just a regular trinomial. There's no GCF, so let's try some guess and check. Okay, so I'm going to go with 2 binomials. Now we could have 1 and 9 or 3 and 3, just for the sake of discussion. I'm just going to go to the 3x and 3x. That gives me the 9x squared. 25, you have 1 and 25, or you have 5 and 5. Typically, people are going to go with that 5 and 5 right away. Let's check it. We got 15x, and what do you know? That's 30x. That works. If you leave your answer like that, that's perfectly fine. But a lot of times, and a habit I want you to start forming, is to take this answer and write it like that. Okay? This is going to be very, very important when we get into chapter 7 later on. Again, there's nothing wrong with this. This is a little bit better though. Now, the fact that this trinomial factored into a perfect square makes it what we call a perfect square trinomial. Now, what's nice about this is if we can recognize this as a perfect square trinomial right away, we don't have to mess with any guess and check. We can literally just jump right down to this. Okay, so how do we recognize that? Okay, let's look at this. We've got a perfect square trinomial will come in one of 2 different forms. The first one is that, or that. Okay, that's the pattern we're trying to recognize within the trinomial. Okay, now when we have this pattern, we can automatically, without any guess and check, factor it like this. And here we can factor like that. Okay, now I remember learning this years ago when the teacher said, here's your pattern. You got it? Good. And I said, I know what you're talking about. Okay. First thing I want you to notice is what's different about these two are these signs right here. And where do they show up? Here. Okay. So that difference right there between the plus and the minus will show up in your answer. Now, again, what pattern am I talking about here? There's 2 main things that we need to recognize. Okay, so first thing, the first and last terms must be positive, perfect squares. I shouldn't have to say positive because if it's a perfect square, it should be positive. But just to accentuate that, I want to make sure that you're aware they have to be positive. So if you have a negative here or a negative here, no good. Okay, that pattern's not happening. Okay, first and last terms are perfect squares. The second thing is that the middle term must equal 2 times the square root of the first times the square root of the, not second, the last. Okay, now what do I mean by that? Literally, what is the square root of a squared? What do you square to make an a squared? Square a. What do you square to make a b squared? You square b. So these are the square roots. Now that middle term has to be 2 times the a times the b. The 2 is just part of the pattern. That's it. That's all that this is trying to get you to do, is exploit a pattern that exists in the numbers. There's no deep, discovery, or it's just the numbers work out this way. And we're trying to memorize and recognize that the numbers are the way they are. Okay. Now, if it was something like this, again, as you can see, we can use guess and check. This whole idea here, if let's say the test comes and you're just drawing a blank, don't use this. This is honestly an optional shortcut if you want to use it, if you feel comfortable using it. If you don't feel comfortable, use guess and check. That will always work, okay, if it's factorable. But if we can recognize this, we can save ourselves a lot of headache. Let's redo this very quickly to see how that would look. If I think that that's a perfect square trinomial, what do I look for first? These have to be perfect squares. Square root of this is 3x. Square root of this is 5. First criteria is met. The second criteria says that if you take these square roots and multiply them and then double it, I get 6x times 5 is 30x. The middle term equals 2 times the square root of the first times the square root of the last. If those two things are happening, I can then take these square roots down, bring this sign down, square it, and I'm done. Now, that may not seem like you saved much time, but if you get good at this, these steps here of checking it to see if it's a perfect square trinomial will take you about 5 seconds. And otherwise, you might be guessing and checking for a minute and a half. So again, give it time. These things will come naturally to you, and they will become a little faster and more efficient after you do it a bunch of times. So please be patient with it. Let's do a few more of these to see how this would play out. Okay, let's see if it's a perfect square trinomial first. Actually, before that, is there a GCF? In this case, there's no GCF. So I could jump into guess and check, or maybe it's a perfect square. I would check that by square root is 4a. Square root is 3. So far, so good. But if I multiply those and then multiply by 2, do I get the middle term? 2 times 4a is 8a. 8a times 3, bingo, 24a. Don't worry about the negative. We're going to take that into account. But the 24a is hit. So I take the square roots. I bring that negative down. And we're good to go. Okay, do you see how quick this can become if you have the process down? And guys, you get the process down by doing it. And that doesn't mean you have to do 100 different problems. If you do 10 problems and you drill them and drill them and drill them a bunch of times, that can be just as, or sometimes more effective than doing, a multitude of different problems. Really know this, the process. Don't worry that it's a 16 into a 4. What did I do? I took the square root. That's what you should be focusing on. How about this? Okay, now be careful. Remember the first step always. Is there a GCF? And in this case, yes, they're all even, so I can take a 2 out. Okay, if I don't take the 2 out, guys, this is not a perfect square trinomial because this isn't a perfect square. Okay, but once I take the 2 out, now things are different. I took the 2 out as GCF. I factored it, but it may not be factored completely. Let's try to go a little further. This, is that a perfect square trinomial? Square root is n. Square root is 7. So far, so good. That's the first criteria. The second one, if I multiply those and then double it. Now, guys, I want to be clear. These 2's are not connected. This 2 is a GCF, separate GCF. This is for that pattern of a perfect square trinomial. I'm putting the 2 there, okay? I get 14n. Bingo. This is a perfect square trinomial. So I can take the square root, this sign, square it. Don't forget, though, that GCF, whoops, comes down. And there's your factored form. Okay? Let's try one more. How about this? First off, is there a GCF? In this case, no. You might say, well, they both have 9s. 9's not going to work for this. So there's no GCF. Let's try the perfect square trinomial, okay? Now, be careful because you're going to look at this and say, well, the square root is 2x, the square root is 3. What's the problem with that? Remember, those square roots have to be positive. This right here, it's not a perfect square trinomial. That doesn't mean, oh, it's prime. That just means I can't use the perfect square trinomial shortcut. How much time did I waste looking for that? Maybe 5 seconds. Okay, but it could have saved me a couple minutes if it was there. Okay, so I tried it. Perfect square trinomial is not there. So my alternative to that is go into guess and check. See if that'll work. So I go back to the 2 binomials. Okay, now remember, 4x squared could be 1 and 4, or it could be 2 and 2. 9 is 1 and 9, or 3 and 3. Okay, let's start guessing. I'm going to start with the 2 and 2. So I'm going to go with 2x and 2x. That'll give me the 4x squared. And then it's a negative, so I'm going to do opposite signs. Let's try 3 and 3. That gives me negative 6x, positive 6x. That's a 0. That's no good. Switching the 3's isn't going to help, so let's move on. Let's try 1 and 9. I got negative 18x plus 2x. Negative 18 plus 2 is negative 16. No good. Switching those isn't going to help because I still have 2's everywhere. So that means 2 and 2 didn't work. Let's go with 1 and 4. Okay, so I tried this, and I tried both of these. Neither of them worked, so this is gone. Then I changed this. Let's try 4 and 1x. Okay, I already had the 1 and 9. Let's leave it there and see if it works. I got negative 36 plus 1 is negative 35. No good. Let's switch them. Negative 4x plus 9 is negative 5. I'm sorry, negative 4 plus 9 is positive 5. No good. Okay, so that means 1 and 9 doesn't work. Let's try 3 and 3. That's a negative 12x plus 3x. Bingo. There's my negative 9x. And there's my factored form. So guys, again, perfect square trinomial doesn't have to be there, okay? If it's there, use it. But if it's not, guess and check is something that we still have to work through and attempt in these factorizations, okay? This was a long discussion. However, we didn't talk about much. We talked about guess and check and perfect square trinomial. These are 2 skills that don't have a lot of upfront information, but it's something that you need to practice. You need to put in the time and just drill it, drill it, drill it. And when you think you got it, drill it some more, drill it some more, drill it some more. When you think you really got it, drill it some more, drill it some more. So it's stuck in your head, and when you need it, you have it at your disposal. This is a very important topic, very important skill. Again, not much to it, but you got to put it into practice. If you have any questions, please feel free to reach out. Keep working hard, do your best, and I'll catch you on the next one.